So graphs and diagrams and other visual representations are pretty common in math and science. And so we also need to think about what are some of the ways that we can actually deal with these kinds of visual representations. And so one of the ways is something known as sonification, where such representations can actually get converted into their corresponding audio. The other way is, of course, getting verbal descriptions for a lot of these images. So there's a software called MathTrax from NASA that basically not only provides you a sonification or an audio representation of a graph, but also provides a visual description of the graph as well. And what I'm going to do is I'm actually going to demonstrate MathTrax to you and show you how that works.
Cortana. MathTrax desktop.
So this is MathTrax from NASA again. This is also, by the way, a freeware, so it's freely download. You can freely download it from the internet.
Equations tab. Enter or select an equation for graphing. Edit combo closed.
I'm going to manually just randomly select some equation.
X equals C1 of 27. Y equals C. Y equals C2 of 27. Y equals X. Y equals X3 of 27.
So let me.
Y equals MXP. Y equals
Let's
MXP.
see.
Y equals X2B5.
Let's do this.
Close. Change parameter C equals edit. Change parameter H equals change param graph description.
So here is the graph description.
Your input equation is y minus 1.0 equals x minus 1.0241.0. The graph of the equation is a parabola. It opens to the north. Focal length can be a measure of a parabola's width, and we can compare this parabola to a reference parabola y equals x2 with focal length 0.25. At 1, this parabola's focal length is about 4 times the focal length of the reference parabola, so this parabola's opening is very wide compared to the reference parabola. What happens to the focal length and parabola width when you change the coefficient of x2? Enter y equals cx2 with c equals 1. See what happens to the parabola. Blank, blank, blank.
So this was the description of this parabola. It tells you what the equation is that you've entered. And now let us hear the audio representation or the sonification of this equation as well.
Graph. Play sounds. Pause. Play sounds.
So basically what happened here is it tries to capture the overall flow, the overall layout of that graph, what is often technically known as the monotonicity of the graph, and tries to convey that information using a variation in frequencies or essentially through audio representation or sonification. There are also other software available that kind of help you do this. So for example, Audio Graphing Calculator is another software. This software, unfortunately, is not a freeware, so this can be available. This is available on a trial basis, after which you need to purchase Audio Graphing Calculator if you were to go that route. This is one of the ways. There are also other ways in which the images can actually be embossed. So this is known as tactile images, wherein the person who is visually impaired can actually touch these images and get an intuition of what is it that is there in the image. For example, it could be an image of a flow chart or a bar chart, essentially, and other such images as well. 3D models these days also are a great option of understanding images as well. For example, there have been a lot of 3D models for DNA, RNA, or the digestive system, and so on and so forth that are now available out there that can also be a viable option.